So let's just go through some of the exercises. Is this still visible?
No, it's
No.
full screen.
I don't know what's wrong with it when we go full screen. Now is it?
No, it's
No,
not.
it's not. Let me do that again. Is it? No.
Try moving your mouse.
Like, is it visible? The screen, share screen.
No, it's
No, it's
usually
usually
frozen. It's still visible but frozen. But yeah, now
yeah.
it's not frozen anymore.
That should work.
I think you
I
can also
think
do it without the
without
meat. It wasn't
it
frozen
wasn't frozen.
before.
No, I'm not full screen anymore. I've
Yeah,
just like extended it and I'm moving the screen. Is it moving on your side?
yeah.
Yeah. Okay. So symmetry, we will be studying symmetry, which is basically same, means same on both sides. And line of symmetry is that position on whose left, right, or up and down things are exactly same. A rotational symmetry. In this case, we can rotate the image and it would just fit in. For example, you would have seen a tiled floor. So we can lift up the tile, rotate it, and put back again. So that is quite possible. And it doesn't need to be fixed in the exact position. You can lift it and fit it back, lift it and fit it back 4 times if you have seen square tiles. It could be done 6 times if you have seen hexagonal tiles. It could be done 2 times if you have seen rectangular tiles. Any issue?
No.
No. So symmetrical order of rotational symmetry, center of rotation, plane symmetry, axis of symmetry, tangent, perpendicular, bisector, chord, equidistant, subtend, arc, cyclic, quadrilateral, and alternate segment. So first of all, image of a triangle, you can draw the line which is vertical in this case. So this is the line of symmetry. Now I can do more, but if it is given that the triangle is isosceles or equilateral. For example, if I say a triangle is equilateral, means all 3 sides are equal. So I can have 1, 2, and 3 lines of symmetries. If someone tells me that triangle is isosceles, I will have only 1 line of symmetry. And if the triangle is scalene, then we have 0 line of symmetry. The line is just like the mirror line to its both sides, the object and image are exactly the same. Same way, 3D objects, we have that in front of us. In 3D objects, we do not say line, we say plane of symmetry. That is plane of symmetry. And next part of this chapter will be parts of circles. It is a mixture with circle properties. So we have radius, we have diameter, we have center, we have circumference.
So is it like a review for chapter 3?
No, no, that will be in complete depth. This start is basically what the recap, and we'll have complete exercise.
Okay.
Symmetry in 2 dimensions. We've just discussed these triangles. That if it is Isosceles, we have one line of symmetry. If it is scalene, we have zero line of symmetry. Now, these are few examples already done. Two lines of symmetry for the rectangle, four lines of symmetry for square, three lines of symmetry for equilateral triangle, and infinite line of symmetry for circle. Exercise. Which of the following broken lines of the figure are line of symmetry with the small mirror or trace and fold the paper? Check with a small mirror. Okay. We actually don't need that. So in a parallelogram, which line do you think is line of symmetry?
EF, and then
That is
AB,
EF is actually not the line of symmetry. And second attempt, I'll explain why. What was the second choice?
and then GH, which is probably not again.
GH, yes, is probably not again.
AB,
AB is not again.
then
And we are left with CD, that is not again.
no, no lines of symmetry.
So we say zero lines of symmetry. Why do we say so? Now let me clear them one by one. Whatever you choose, for example, I'm talking about EF. See, this angle is less than 90 and this angle is more than 90. Can you see that clearly?
Yep.
And it works with all the possible options. If you would fold this on line EF, you will find D somewhere here and you'll find B somewhere here. This is how you'll be folding it. They're not overlapping over each other. An oval, which is the line of symmetry.
CD,
Correct. And
AB,
CD, yes. AB is actually not, EG is. I'll draw an exaggerated oval to explain. This is an
yep,
exaggerated oval. So
no.
vertical and horizontal line, yes. And that's a no because we have bulge on this side and no bulge on this side.
So it
Clear?
only has two lines of symmetry, then CD and HG.
C, B, C,
CD
D, yes. And a
and
G, yes. Only two lines of symmetry. Because if you see closely, this end is a little elongated and this is a little curved, more curved.
yeah, the triangle for A is like larger than the triangle for E and G.
That's right.
It allowed to be equal.
That's right. Now, if I draw a rectangle, how many lines of symmetry are there?
Two,
Correct. Now I'm drawing a circle here. How many lines of symmetry are there?
infinite.
Zero for this complete shape.
Do you mean for the circle? Oh, you mean the complete
Uh,
shape.
The complete shape. The complete shape.
Oh, yeah, because the circle would ruin it being equal on all sides.
If I just draw this, now I cannot see both sides same.
Yeah,
Now how many lines of symmetry are there?
there is one.
There is one, yes, which is horizontal. Okay, what was the main question? Which of the broken line of figure is line of symmetry? Yeah, rectangle. Which one is line of symmetry?
CD and E.
Correct. C D H G. D part, doctor. Isosceles trapezium. Which one is line of symmetry?
AB.
A, B, only one. Yes. E part, rhombus. Rhombus
EF.
is a tilted square.
Yep. EF and EB and CD and GH.
In case of a rhombus, EF, yes. AB, yes. All other, no.
CD no.
CD, no. Let me draw an exaggerated rhombus. Rhombus is actually a parallelogram, but all four sides are equal. Only that is why AB and EF is possible. Now see, this angle is actually more than 90 and this is less than 90. Do you see that obtuse and acute angle?
Yep.
So it is not symmetrical. So torus, around which two lines, or did I say two? Around which line is this trapezium?
AB and CD.
ABCD, correct. G part. L shape, line of symmetry.
CD.
Correct. Hexagonal pentagon.
AB.
A, B is correct. There's one more.
HG.
That is correct. Now, if these lines were not there, how many lines of symmetry could you draw for this 2D shape?
5.
Very good. Now, this is a small exercise. Square, how many lines of symmetry?
4.
Rectangle,
2.
equilateral triangle,
3.
isosceles triangle,
1.
scalene triangle,
0.
kite.
1.
Kite is one. Yes, the diagonal one. Parallelogram,
0.
rhombus.
Rhombus 1.
That was two.
Oh, yeah. The extra one.
One this.
Yeah.
This. A regular pentagon.
5.
Five. Regular hexagon.
6.
Octagon.
8.
Copy these figures and draw all the possible lines of symmetry. So I think choose any two. We'll do that them now. 1, 2, 3, 4, 5, 6. Image number
4 and 6.
4 and 6. So I have to draw all the lines of symmetry. When I'm looking at the fourth image, I can see I can draw four lines. Two through those arrows and two actually in the diagonal. And the last one is 1, 2, 3, 4, 5, 6, 7, 8. So we can draw 8 horizontal lines passing through the vertices. 4 done. Fifth is this inside point, the inside point. 6, 7, and 8. That would be much easier with pencil and paper and scale. A slight practice exercise applying your skills. The children in the primary school Class, make shapes for the class pattern by cutting out a design. Draw on the corner of a folded piece of paper. Draw the shape that will be produced by each of these cutouts. So, what do you think would be in the first shape?
Circle.
That's right. It will be a circle. Now I'm going to try fourth part. So when I just open it, basically I can see this shape. I've just drawn that shape, or let me draw it in exact copy paste. See, this is the exact copy paste of the red line, and we actually have two lines of symmetry which are folded. One of which is this blue line, and the other is this red line. So if someone asks you to complete this image, yes, we can do that. And there you go. So once done against the red line of symmetry, now we're doing against the blue line of symmetry. So one would need a strong imagination also to draw this, but the best way is draw these two lines and then you can sketch clearly. I'm doing the last one. So this is it, and I'm going to draw the line of symmetry. See, you see this folding line, that is actually line of symmetry, and this folding line, that's line of symmetry. So I'm using the vertical line first and completing some of the image. Now I'm going to use the horizontal line as well. And this. Clear? Any
Clear.
issues imagining these shapes?
No, it's just copying it down all the full boxes.
Hmm. Number 5. Find and draw the badges of 5 different shows. What was the question? Draw the shapes that will be produced by these. Done. Show the line of symmetry on each by means of dotted line. I actually didn't read it, so I should have made dotted lines. Question number 5. Find and draw the badge of 5 different makes of motor vehicle. Indicate the line of symmetry on each drawing. Do you know how a BMW sign looks like?
Yes.
So we'll just draw this. And now, can you tell me how many lines of symmetry are there?
Four.
There are only two. This is one. Do you see the exactness on either sides?
Yeah.
And then this is two. The vertical one is not, because on right hand side there's red, on left hand side there's white.
Yep. So two.
Yeah. I just remember, I'm trying to recall these symbols. The other one is Mercedes. And how many lines of symmetry can we have in Mercedes symbol?
Three.
three. Tesla, I guess.
One.
What? Can you remember any brand?
There is the
Are you familiar with Hyundai?
yeah.
I think I think if I'm not wrong, it is of lesser width at the top and more at the bottom. So this would be one line of symmetry. And any
Like
fifth
also Audi.
Audi. So one, two, three, four rings and one vertical and one horizontal line of symmetry. Okay, rotational symmetry. Again, if we talk about the square tile, and I'm going to name it for easy communication. So if I name this side A, then side B, then C, then D. So if I just lift it up and rotate it, I can exactly fit side A on place of side B. And this will look like this. And I can do so four times. And after that, A will be exactly back in its own position. So I moved it once. I'm moving it twice. A, B, C, D. I'm moving it thrice. A, B, C, D. And now I'm moving it fourth time. So A, B, C, D. Moving it four times brings it back to the original position, original shape. So I will say the order of rotation for a square tile is 4. On the contrary, if we talk about a rectangular tile, it could be lifted only twice. This is side A, this is side B. You rotate it 180 degrees only, then it will fit in its own position. Then you rotate that again, and it will fit in its own position a second time, first time and second time. How much can we rotate? We can rotate 360 degrees in total. And during those rotations, we have to see if it will fit in its space or not. So square have order of rotation 4, rectangle has order of rotation 2. State the order of rotational symmetry of each of the following polygons. The dot represents the center of rotation in each. So, what do you think will be the order of rotation in the first diagram A?
Two.
Correct. Order of rotation in B?
Five.
5. Correct. C?
One.
That is 2.
Two.
C is corner capital A and capital B. When you'll rotate, A would land on B and B would land on A. And then you can rotate it 180 degree again to bring it back in the original position.
Okay.
D part?
Six.
6. E part?
Two.
Very good. F part?
Also two.
That is actually 1 because this side is small and this side is longer.
Okay.
You see, if I just number them A, B, C, D, A can actually fit in B. But in the meanwhile, B is moving towards C and it cannot fit in because B and C are different.
Okay.
G part.
Two. Two, I think. Yeah. Yeah.
You lift it up. Now, see what we actually do. Suppose, consider this is a tile. and I place it on a white graph or chart paper and draw the boundary. Now you have to lift it and rotate it and drop it. Do you think it will fit in the exact shape? Look at the first one. It fits in the exact shape even after lifting and rotating. When side A goes to side B, it just fits it. And it does that two times in 360. B part
So
does that
G is
five
1
times in 360.
because it
Yes,
won't.
because it won't fit. Uh, it will only fit when it is rotated 360 degrees.
Mm-hmm.
And H part,
1.
1. Yes. This table shows how many lines of symmetry are in 6 regular polygons: triangle, quadrilateral, pentagon, hexagon, octagon, decagon. We have to discuss the order of rotational symmetry. For triangle, what would it be?
3.
That's right, 3. Quadrilateral is a four-sided figure,
So
and
4.
it is such quadrilateral that it is having already 4 lines of symmetry. So order of rotation will be
4.
4 because this is actually a square. Pentagon, order of rotational symmetry:
5.
5, 6,
Yep.
8, 10.
But it didn't say it was regular. But it does have 5 lines of symmetry.
They never said it was regular, but lines of symmetry are actually confirming it is regular. If he would have said 1, this would have been isosceles triangle. But it said 3 lines of symmetry. So that is confirming that the triangle is a regular triangle.
Okay.
Same goes for quadrilateral, 4 lines of symmetry. There's only square which has 4 lines of symmetry. Draw each shape and investigate its rotational symmetry. We already understand that in words for now. Sometimes it helps to physically turn the shape. Yes, that is just a practice. I'm trying to draw and use some words to explain, and you're responding in a right way. So I think you're getting it. So see, copy and complete and fill the order of rotational symmetry. Describe how the line of symmetry and rotational symmetry are related in regular polygons. They're equal. Line of symmetry and order of rotation are equal in regular polygons. D-Bart says, what pattern can you see relating line of symmetry, order of rotation, and number of sides in a regular polygon? Actually, all are equal. Any objection? Can you think through this?
Applying your pattern, do you see? Do you mean D or 3? The motor batch, right?
Which one are you asking?
Can is it apply your skills for 2s and 3?
So, sorry, which part are you talking about? A, B, C, D?
You're asking about D, right?
D, yes. What
Okay.
pattern can you see relating the line of symmetry, order of rotational symmetry, and number of sides? So we've already observed that they are equal.
Yep.
Line of symmetry only in regular shapes.
So we would have to say it's all equal after.
Yes. If the shape is not regular, such as parallelogram, we have 0 lines of symmetry, but we do have 2 order of rotation.
But it's different from regular polygons, so we don't have to write that, right?
Yeah, that's still a polygon, but not regular.
Yep.
I refer back to a motor vehicle badge you drew in this for one state. Its order of rotation symmetry. So BMW, what's the order of rotation?
BMW.
Okay, start with Mercedes.
Okay,
What is the
Mercedes.
order of production?
Mercedes 3.
Three, right. Audi,
Audi would have 2.
very good. Mercedes, sorry, BMW,
BMW would have also 2.
order of production, yes. Number four, using a computer print out the. So that's basically a practice exercise. We can write A to Z and then draw the line of symmetries only in capital alphabets. And then we can discuss the order of rotational. Okay, let's see. Name any letters which has only one line of symmetry. I'll start. I'll say
Um,
capital A has one line of symmetry which is vertical. What else do you think has one line of symmetry?
Y.
Y has one, yes. Capital T has one. Capital W has one. How many lines of symmetry does M have?
M also has 1.
M is
Z.
also one, yes. Oh, no, not three, one only.
Z. Doesn't
Z
Z
has
only have 1?
zero lines of symmetry.
Sorry?
Z will have zero line of symmetry.
Okay.
See, this is Z. So this is not the line of symmetry, and this is not the line of symmetry. Any
Mm-hmm.
objection that how is it or how is it not? See the blue line on right hand side we have a point and on left hand side we have a single line. So it is not same. Then the orange line, same explanation.
U.
U, yes, one line of symmetry. V is one line of symmetry. B, ball is one line of symmetry.
H.
H is two lines of symmetry. Okay. So it has more than one line of symmetry. We just discussed two. And the third part says a rotational symmetry of order two.
Well, there's H.
H,
And
very good.
there's also O.
O would be infinite,
So 2 or more.
two or more, yes. So after H, may I write capital I?
Yep.
So these are the few examples. Symmetry in three dimensions. So far, we've done almost all the questions, nothing for the revision, and this is an easy topic. Are you getting it?
Yes.
Planes of symmetry. Whatever we were doing with the line, now we are dealing with 3D objects. So we'll use the word plane of symmetry, not line. So as you can see that three of these slices are already drawn. There are different slices as well. We can do that. So planes of symmetry, can you pretty much imagine when you're looking in at these three shapes that yes, this would be plane. For example, consider that you have a square cake. How many planes of symmetry do you think this square cake will have?
4?
Okay, if you have a square cake, you are actually imagining on top. So if you're looking at the top, you have four lines of symmetry. When you penetrate those lines of symmetry with the knife, you're actually making a plane of symmetry. So assume that your cake is like 4 inches high, like this. If it is 4 inches high, so do you think this will be a plane of symmetry if I just slice it through 2 inches?
Yes.
So it will be 5. In case of a regular 3D shapes, it is sides plus 1. For example, we say that I have a semicircle. How many lines of symmetry are there?
There's only one.
There's only one. So if I just convert it into a 3D shape, then how many are there? That's a plus 1 because I can slice it in between now. So same way, if I just have a trapezium and another trapezium connected with each other. So if there's no line of symmetry at the top, I can still make it half. What do you say? Getting the point? I think sometimes the voice skips.
As sometimes the voice stops.
Yeah. The diagram shows two possible cuts through this sphere that produces two identical halves. The sphere has infinite number of planes. And yes, it has infinite. Okay, let's think over these questions. Here are two of the planes symmetrical in a cube. Cube has 9 possible planes. Make sketches to show other 7 planes. Okay, that would be a very long exercise if we try to sketch it. So just draw a cube on a piece of paper and try to imagine where you will find those total 9 planes of symmetry. If you can, very good, or else I'll show you.
I sketched a cube, so now I just have to like cut it where the plane would be.
Say that again.
I sketched a cube, so now I have to cut it to a plane where a plane would be.
Yeah, actually, what you do is that would be very difficult to explain in words. I can sketch and speak. You're just speaking.
Okay.
So just try to draw, and I'm pretty sure that you'll be able to figure out that yes, this is one, this is two, this is three. For example, I'm drawing on the same one, this horizontal plane. Would you agree to this?
Yeah.
So these are in total three now. Two are already done. We did the third one, and this is the fourth one, right?
Yes.
And on top, okay, I'm just counting on left hand side first. So one, two, three. Three are done. Now see on right hand side, fourth one
We do
already
all of
diagonal,
them.
and then I take the diagonal on this side and end it over here. So one, two, three, four, and this is 5. Then 6 is the diagonal. This diagonal goes down complete way, and 7 is this way diagonal goes down the complete way, and I'm changing color. You see this diagonal right away and goes completely to the left, and same way changing the color again. This diagonal goes till the end. So these are 9 planes.
That we added on. But for the second cube, wasn't there already two diagonals?
No, I'm not counting those red. If we count those red, then we have total 9.
Okay, but if we don't count
Let
it,
me number them.
okay.
This blue in 1, this brown is 2, this horizontal green is 3, the vertical green is 4, the one that is already given is 5, coming to right hand side. This diagonal is 6, the other diagonal is 7, and the one that goes top to bottom is 8 in the diagonal, and top to bottom in the diagonal again is 9. And I think this one is repetition. Left side brown, fifth number, and red on right side. So if I just ignore this one, and I'll find where is the missing one.
Don't cubes have 5 like planes of symmetry?
We can draw this way. Sorry?
Don't cubes have 5 planes of symmetry? So if it wasn't two
No, no,
cubes,
no, 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 no. Don't confuse it with this thing. When we drew the cake thing, okay, there were
mhm,
one line of symmetry, two line of symmetry, three line of symmetry, four line of symmetry, and fifth one was through it. This time, this is not a cake because the fourth dimension was actually not equal. This time, the last dimension is also equal. So basically, when we have this, one line of symmetry is through this line. Okay, one. Done. Agreed.
yes.
Okay, this was a cube. Now that's one in red. I'm drawing another one in red. Horizontal, two. Done. I'm doing another red. This diagonal and through at the ends is 3. Another diagonal changing color. This diagonal through till the back end is 4. Now I'm slowing down. I'm coming on the top horizontal 5 and drawing a diagonal on top is this is 6 till the bottom changing color. 7 is another diagonal at the top till the bottom. Top diagonals are done. Now I'm coming to right hand side. This diagonal is 8 and another diagonal is 9. So 9 planes of symmetry. I think let's use this as well. You see this one? This is actually not a cube. Yeah. Can you see these 9?
It's still freezing up, but I can see it.
Yeah. This is at 1 minute and 9 seconds. And save this link. Right. 1 minute and 9 seconds. It's showing all the nine faces. Okay.
Okay, I got it and I paused it at that time.
Yeah. Question number two. How many planes of symmetry does each of the following solids have? First one, I think, is four.
Yes.
How many planes does B part have?
Infinite. No, wait. It's not, but it's not a sphere, so it's infinite still because it's a circle.
Just a second.
Yeah.
Okay. So C part is a sphere, and that again would be infinite. How many planes will be in D part?
Two.
One, two, right. E part,
Two.
right. F part,
Two.
I think there are more than two. The base is actually a square.
Seven.
Seven?
Maybe.
Those are four. Consider all the four lines of symmetry in a square, and which would converge to the point on the top. Consider a knife, place it at the tip on the top, and just slice it down on the square, making four lines of symmetry. That will make four planes of symmetry.
So there's four planes of symmetry?
Yeah.
Because I was
See the
thinking about the triangles. I was saying because it's an isosceles and it has two,
yeah,
like
yeah, see this. See this. If you are thinking about the triangle, this would be one of the line, right?
mm-hmm.
And this is the other line. These are two. Now see the diagonals of the square, the base. So it would pass through this point and these edges. First, you were passing exactly between the triangles. Now you're passing the knife through the edges and another one through that dotted line and this solid line. So four lines, so four planes of symmetry.
Okay.
G part. This complete chapter is actually thinking, exploring, and discussing.
Does it have? I don't think it has infinite because of the because of the cone shape, but
See again, if you just pick a knife and place it at top,
mhm.
place the knife at the top, so you can slice it through at many different points because you have infinite lines of symmetry of the circle.
But there's
So it
only
has a,
one point that we can pass it through, the top.
yeah, yeah, yeah. But you can, like, you placed your knife this way, you're holding it, then you just move it by 1 degree, and then you move it by 1 degree again, and keep slicing, slicing, slicing.
Yeah, for the circle. But would there be enough space to do that on the point?
You don't have to worry about the space because we are not making the actual cuts. We're just imagining.
Okay.
Uh, there was a diagram. This circle, see, infinite. So
So,
consider that now you're looking at that cone from the top. This is how it would look like.
oh, I see. Because that's
And
like the middle red is like the point.
yes, the
Okay.
one at the left would look like the triangular base, and this would be the pointed tip of the triangle, making
Okay.
it look like as a pyramid. H part,
7,
very nice. Last one, I part,
2.
very good. Those both are from the top and downwards. These are not exactly where these should be. So center to center and center to center, and the knife passes all the way down. Hmm. Okay. We'll inshallah continue from here tomorrow. No homework for today. Is it okay?
Yep.
This is
I can just go over like the pages. Because I already have the book with me.
okay. Fine. That would save time.
Mm-hmm.
That's right. Okay. Take care. See you tomorrow.
Okay.
Okay. Now, rotational symmetry is that imaginary axis. If you can see in the first one, axis of rotation, that you rotate, and if someone exits the room and enters again, he won't notice that the object is being rotated. For example, you place an A4 page. This is an A4 page, and you just flip it upside down. So someone who enters the room again will not notice that if it is being flipped or not. Meanwhile, we may talk about 3D objects. And let's say this is a shoe box which is identical on all sides, like the color is same. So if we just flip it, so the person will not know. On that axis, it is axis of rotational symmetry. For example, if I just draw this 3D image, will you agree that I enter this center point and leave this center point? This axis could be the axis of rotation. This red one, will you agree?
So it's basically a point where you can move the shape and it will look the same or rotate
Yes.
it.
Like if I will rotate it 180 degree, no one would notice that it is being rotated. But if I change the position slightly, like I enter this point and then I leave this point. Now to right side, basically what I've done, I've entered this position. Now if I rotate 180 degree, after rotation, it would be noticeable because if the person who saw it knew that there's longer side on right hand side, now there's longer side on left hand side. But if it would have been passed through the center, then it will go unnoticed. So that point is axis of rotation. And for this same shape, I have three axes of rotation. I pass through this point, exit through this middle one, then I pass through this point, exit through the other middle, and one is vertical. Pass through this point, and this. So these are the points where it could be rotated and will go unnoticed. Clear?
Yes.
So these are the three for the given shape. Okay. It says the diagram shows three possible axes of symmetry through a cuboid. For each of one, state the order of rotational symmetry clockwise through 360. So order of rotational symmetry. Now these axes are given. If I rotate it 360, I'm labeling it A, B, C, D. So if I rotate this 180 degree, AB will come on this side and DC will come on this side. This is 180. Then I rotate again 180, it will come back to its original position. So there are only two positions where it could be rotated. It cannot be rotated at four different positions because it is a rectangle. Second again is two different rotations. Third again is two different rotations, 180, 180. If I talk about question number 2B, there's only one rotation because whenever we will move this, we will rotate this blue line, it will come on some other side and will be noticed. So if it rotates 360 complete, only then it comes back to its original position and goes unnoticed. Same way, the first one has infinite different positions. Because we have this drum axis is passing right in center, so we may move it to infinite positions and it will be unnoticed. What do you think about C part?
I think that it can be moved 4 times.
C part is four times if we consider it a square, but I think it seems like this is shorter and this is longer. So what would it be if it is a rectangle?
So only 2 times.
It would be two times, yes. D part,
I think it can move 8 times.
Very good. E,
Infinite.
infinite. F,
Once.
once. They didn't ask about the cube. Cube has 13 axes of rotation, 9 planes of symmetry, and 13 axes of rotation. Whenever it comes in exam and they tell you to count them, just write 13. That 13. Don't waste your time in counting. During practice at home, you may give it a try that how is it 13. If you
Okay.
succeed, it's good, or else we can discuss together. Symmetry, properties of circles. First property is chord and radius. If you can see the circle on right, AB is the chord, and if we draw radius through center, or we draw the shortest distance which is actually perpendicular, so it is symmetrical on left hand side and right hand side. So that's the symmetric property. And if I just draw these two lines, that is radius and radius, now I have two congruent triangles working on the same property. Chord AB is drawn in the circle with the radius 7. 7 is given. If the chord is 3 centimeters from the center, 3 is given. Find the length of the chord. So I'm using 7 and 3 to find PB. Applying Pythagoras theorem, 7 square is equal to 3 square plus PB square. So PB is equal to 49 minus 9 is square root 40. So if PB is square root 40, this complete is 2 square root 40. Any doubt?
No.
Now same way, if you see the diagram, we have two different positions. For example, I'm going back again in the first worked example. If I just draw this line and I say that the distance from the center is 4, will this new line xy, will this be longer than AB or shorter?
It will be shorter.
That will be shorter. So if I don't write that 4 and I write that this is 2, so what would be xy? Longer or shorter?
XY still is shorter.
It would now be longer. You're just looking at the
Do you
image,
mean
but
from AB or do you mean the line itself?
from O, if the distance from O is 2, then the length xy will be longer than AB.
Okay.
You see, this was AB and this distance was 3. So if I just increase this distance, move it away from the center, see, it becomes shorter. It becomes even shorter.
Yes. So because it moves, XY moves closer to the center, it makes it longer.
Yes. See this green line, when it comes closer and when it actually passes through, it is the longest. That is the diameter. So it is further away means shorter. Let's say this is the line. This is the chord. If I move further away, that gets shorter. So if someone is already telling that the distance is equal, that means AB will be equal to DC. Okay. O is the center of the circle, radius 11 centimeters, already given. AB and CD are chords. AB is equals to 14. If AB is 14, may I say XB is 7 and AX is 7?
Yes,
And it
because it's
says
hot.
OX and OY are equal. So if these two are equal, that means the chord lengths are also equal because they are equal distance away from the center. So this is going to be 7 as well. Now we can find OY using Pythagoras theorem. Okay. Now this is tangent property. This was perpendicular, and if I just keep moving away, but I'm just extended these outside as well, this is still 90, and I keep moving till the line goes outside the circle, making it a tangent. So the property is that radius and tangent are perpendicular to each other. So if this is a tangent, this is 90 degrees, and tangent on the other side is again 90 degrees. So I can say this is radius, this is radius. These lengths are equal. Center line is obviously common. So whatever is in this triangle is equal to this triangle. These two are congruent triangles. Property is known as two tangents from one external point.
So the one like extending is the same as the one that's like in the shape of a triangle.
Yes, shape of triangle, all angles same, all lengths same. OAP is equal to OBP.
Oh, okay.
So same goes for this. I can directly copy without solving that this is 25. And without solving this is 12. That was actually not needed. So x is 25, and to calculate y we can use Pythagoras theorem. Y is the longest side opposite to 90 degrees. So y square is equal to 25 square plus 12 square, and simplifies to square root 6 769. X and y needs to be found. 30 is already given, and we know radius and tangent. This is property, this is 90. So 180 minus 90 minus 30 is equals to y is equals to 60 degrees. So if y is 60, these two are obviously congruent. This is also 60. Calculate the length of chord AB. Try this. I'm getting the first one, AB is equal to 5.
I'm getting the answer higher than that. Can you like show me how you did it?
Yes, I'm looking at AX only. So 6.5 square is equal to 6 square plus AX square. Now this goes on the other side and gets subtracted. 6.5 is the hypotenuse. So AX is equals to square root 6.5 square minus 6 square. So we get 2.5 for that. AX equals 2.5 and AB is twice of AX.
So 5. Yes.
So 5. Try B part.
Mm, 30.
That's right. Let's do question number 2. P is a point inside the circle whose center is O. Describe how to construct a chord that has P as its midpoint. P is a point inside the circle whose center is O. So basically, P is this point inside the circle whose center is O. Describe how to construct a chord that has P at its midpoint. So if this is P, I'm removing this diameter. Now, how can we construct this? If I try to draw a chord and I pass the line like this, like why is he even asking that? That's very easy. We just place a ruler anywhere. Mm, P at its midpoint. Oh yes, yes, yes. If I draw it like this is not the midpoint. So if it is the midpoint, it has to be as we studied in the property. This is the midpoint. So it has to be 90-degree. So one thing is I can draw the radius passing through P. If this is P, from center to this is P. And now I can place my ruler and we have markings on the ruler. And these markings are 90-degree to the line. So we can just place the ruler and marking 90-degree and you can draw this. The other method is a bit longer. We can use compass and try to make perpendicular bisector.
So the line has to line up with the ruler's longest line?
Yes,
Okay.
that would be easy to compare as compared to the shorter ones. A straight line cuts two concentric circles at A, B, C, D. In that order, prove that AB is equal to CD. Okay. So if I just draw this line and mark this as 90 degrees and then draw C and B, I'm labeling this O. OB is equal to OC. because we know it is radius, right? And
Yes.
secondly, if I write this as E, a straight line cuts two concentric circles, common center. Mm, These are congruent triangles. So BE has to be equal to EC. Just using the property chord and the line, BE is equal to EC. On the other hand, I can say that AE is equal to ED, right? AE is equal to ED because the transverse line splits the chord into equal half. Now on left hand side, AB is actually plus BE. On right hand side, ED is actually EC plus CD. And we've just shown that these two are equal. It could be separate, subtracted on both sides. So AB is equal to CD. And these are just the practice questions. In exams, we have numericals like the one we did in question 1 and these worked examples. And now in question 4, try the first one. I'm getting 17.3 for the first one. Still doing?
Yes. So I know that CD and AB are equal, and also EO and OF are equal. But then I know diameter is like going through the center and it's full,
So
going
we have
through
to find
both
actually
sides.
OA or OC or OD or OB. That is the radius. And then you just multiply it with 2.
Okay. So OC or OF. What? Right?
Yep. See, this full is 11.4.
Yes.
Half of which will be 11.4 by 2 is 5.7. And then the distance is 6.5. So I can find this OC using Pythagoras theorem. OC squared is equal to 6.5 square plus 5.7 squared. So
Oh, I
OC is
see.
equal.
So that's why it equals to 17.3.
Yeah, this is OC. And diameter is 2 times OC.
Yeah, yeah.
So 2 times square root 6.5 square plus 5.7 squared. Now use calculator to get 17.3. Up to 3 significant figures.
$17.29.
Yeah, so it rounds to 17.3. Try B part.
4.25 or yeah, 4.3.
4.25, 3 significant figures.
4.252. Oh, no, 4.25, yep.
Yeah, 4.252 is 3 decimal and 3 significant is 4.25. Let's try question number 5. A circle with the radius 8.4 and chord 5 centimeters from the center Radius is 8.4 and chord is 5 centimeters from the center. So if this is 5, this is 8.4. The circle with radius 8.5 and 5, calculate the length of the chord to two decimal places. So I have to calculate this. So let's calculate the half first. 8.4 square is equal to 5 square plus x square. 8.4 square minus 5 square whole square root equals x, and then times 2.
13.49, so 13.5.
Yes.
Yeah.
Centimeters. Try question number 6.
For AO, I'm getting 3 centimeters.
15 is hypotenuse, 12 is one side, and
Yeah.
AO
I
is the
subtracted
other side.
Yep. I subtracted
Ah,
15
no,
from
no, no
one.
subtraction. Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. No subtraction.
Oh, okay.
This is Got time?
Yep, I got 9. I'm just solving the area. I'm also getting something different for the area. Can I just show you how I did it?
Yeah, sure.
Okay, so I solved it by getting the two areas of the triangle. So firstly the ABO, and I know that x is 9, so I just halved it. So I did 4.5, and then I found like the
Uh,
height of it. Yeah, and then I found like the height
just
of
let
it.
me know. So what the height is?
So I got 14.3 for the height.
Height is 12. See, this is perpendicular. Base is 9.
Mm-hmm.
Height is 12. If I
Because
just
oh
move this way,
yeah.
it's perpendicular already.
Oh, okay. So yeah, that's why I got a little higher. I'm gonna try
And
it
we
with
have
12.
two such triangles.
Yep.
So that's 108.
So just 12 times 9 and yeah, 108.
Yes. Okay. Look at number 7. In the diagram, AB and AD are tangents. Okay. To the circle, and be careful. Tangent is only perpendicular with the radius. So there is no 90-degree at B. ABD is not 90. CBD is not 90. In the diagram, AB and AD are tangents to the circle. ABC is a straight line. Calculate the size of angle X. You think you can do that?
Yes, I can try.
Goodness.
33.25.
Angle x,
Yes.
I think it is. I think it is 43. Just ignore the line BD,
Mm-hmm.
and this is 90, and that's x. 47 plus 90 plus x is equals to 180.
Oh, I didn't think of it that way. But I did it in like a different way. Is ABD an isosceles?
ABD is isosceles, but AB and AD are equal.
Yes, so that means that B and D are both equal, right?
Yes.
Yes.
Okay,
So,
let's do it that way.
okay.
Now there are two things actually. Even if we do this, these two are equal. So 180 minus 47 is 133. 133 by 2 is 66.5. Both of these are 66.5. But where does that take you? B, C, and BD are not equal.
So BCD is not isosceles.
Yes. So if I just find this one, this is 180 minus 66.5, and I'm left with 113.5. 113.5. On the other hand, you're bound to use this 90. So 90 minus 66.5, we're left with 23.5. Now we can use these three. 113.5 plus 23.5 plus x is equals to 180.
Yeah, because I saw BCD as an isosceles triangle. But no, it's not.
In math, we are never imagining. No guesses, no imagination. Everything based on the given data.
Okay.
Okay. Angle relationship in circles. Just look at the diagram on the right and nothing else. Is the diagram clear?
Yes.
So AB is the diameter of the circle, C is the center, and D is the point on the circumference. Remember that all of the radii of the circle are equal, so no doubt AC, DC, BC are radius and are equal. And if they are equal, it is definitely isosceles. So that is why the two base angles x and x are equal and y are equal. And we can also solve that x plus y is equals to 90, because all these three corners, x plus y is equal to 180. Then we take out two common, and this line at the end bottom of the page, x plus y is equals to 90. This one other property, indirectly we are doing that. I'll tell you when we reach there. If you draw diameter and you draw any angle on this diameter, but it should touch the circumference. So I'm drawing these two straight lines. This is 90. I'm drawing another line. This is again 90. So this is also a property. So I can tell you that this is 90 degrees. The angle between the tangent and the radius is 90. We've already discussed it. Look at the diagram carefully. You read. You already know that the diameter divides the circle evenly into two equal parts. So A is equal to B, and A plus B is equals to 180, and A alone is 90, B alone is 90. Calculate the size of the lettered angles in each diagram. Question 1A. 1A, I'm getting these answers.
So x and y equal to 43 and z equals to 94.
Yes.
What? Oh no, I'm just writing what you got because I'm trying to figure it out.
See, mm, Do you agree that this OA and this OC is radius?
Yeah.
So this should be 47 isosceles,
Mm-hmm.
right?
Yes.
Secondly, if these two are 47, I can just subtract these two to find this angle, which is 86. And now I can subtract this again from 180 to get this 94. Once done, 94 minus 180 divided by 2, I'm getting 43 for x and y.
Right, because that's also an isosceles because the radius are the same.
Yes, OC and OB is again the radius.
Isn't AO and OB also the same, right?
Yes,
But because they're not equal, because CB and AC are different.
angles are different, length are same.
Okay.
Yes,
Oh,
CB
no.
and C.
Yeah.
Now see this. Mm, this thing. See, whatever you draw on the diameter, wherever, not whatever, wherever you draw, but it should touch the circumference as 90 degrees. So I've used that property first. That makes it very quick. So if this is 90, this is 47, the third one is x. 47 plus 90 plus x is equals to 180. And we straight away get that x is 43. And now I know these two are isosceles. If this is 43, this is also 43. Subtract both of these from 180, you get z.
Okay.
Same way, this is 90. This is 90. Angle ABC is already given that it is 60. So if that is 60, when we remove 26, I'm left with 34 at the upper half. Angle A is already 90. So subtracting these two, I can find this angle. 180 minus 90 minus 34. I get 56. So x is equals to 180 minus 56 is 124. And we can find y. This is 56, opposite angle is 56, and y is 34. Is this clear?
Yes, it's clear.
Try C part.
35.
That's right. 110 comes down here, vertically opposite, and these two are x.
Yes.
Plus x plus 110 is equals to 180. X is equals to 35. D part. So again, this is 90 because it is on diameter, and x alternate angles. 42 plus x plus 90 equals 180. Let's do these two as well for today. Calculate the value of x in each diagram, show your working, and give reasons for any deductions. Okay, now this thing is new. Give reasons. Whatever we've been discussing are the reasons. We just have to write it. So find x.
41.5. Because triangle AOB is an isosceles triangle,
Very nice.
and the two missing angles equal to 48.5. And since that OBE is perpendicular, so it's a 90-degree angle. So we just have to subtract 48.5 from 90, and we got, what did I say?
41.5.
41.5.
Very good. One more. B part, last one. I think that is exactly the reverse and opposite of what we did in A.
Yeah, now we're trying to find inside. $38.
That's right.
Because uh it's CAO is a 90-degree angle, and we subtract 90 from 19, and then we get 71, and then 71 times 2 subtracted
Yep.
by 180, which gives us x.
71 times 2 will tell that it is isosceles triangle.
Yes.
And then we can get x. Okay. There's only one question left in this exercise, and then we'll have new properties. So you can just take a screenshot to try this third person.
Okay, is there any more parts to the 3?
No, just this one. We'll
Okay.
just double check. Yeah, there are. Thank you. There are. So we'll make two screenshots, or the question will be very small.
Yep.
Then,
Yes.
and this.
Okay, got it.
See you in next class. We'll discuss this question and then go through the new property.
Okay. Thank you.
You're welcome. Take care.
Bye.
Bye. Stuck somewhere.
Oh, okay.
You were saying you needed to confirm one answer.
Yes. I don't remember which exercise it was, but I remember it was a question 3.
Okay. This is something we've been doing completely without leaving any questions. This is one of the question 3 already done. And this question 3.
Yeah. I just need to check question A. It's downstairs. Yeah, downwards.
Okay. Explain why triangle ABC is isosceles. Property, straight away property. Two tangents from one external point. These two tangents are equal.
Mm-hmm.
So we'll just mention that these are two tangents from one external point.
I said that AB and CB is equal, and
Yes.
I said that A and C is equal. That's why it makes them isosceles. Because in an isosceles triangle,
There's
there's
only one thing we need to say. Either we tell them the angles are same or we tell them the lengths are same. But in this case, clearly, because this is in property, two tangents from one external point are always equal.
okay. I just mentioned that AB and CB was equal. I also need to add that two tangents from an external point are equal as well, right?
Yep.
Okay.
And B part also?
No, B part is clear.
Okay. Okay, this is a second problem. Name of the property is angle at center is twice the angle at circumference. You see this circle? This is the center.
Yes.
Radius, radius, and then the radius reflects back, hits and reflects back and meets at the circumference. So if this angle is x, this angle is 2x. Angle at center is 2 times the angle at circumference. Angle at center is 2 times the angle at circumference. Now we always have to recognize it, but it appears in different forms. For example, let me just name it A, B, C. I'm changing the position of point C, and it changes in such a way that it gets close to the radius. This is still 2x, this is still x. Clear?
Yes.
And the third position, now I'm bringing C even further down such that it exactly overlaps the radius. So when we see such shape, we have to recognize that it is still angle at center is twice the angle at circumference. I'll show you with numbers that will enable you to understand more and memorize it. For example, I say that this is 60. So this should have been 30. Angle at center twice the angle at circumference. So if that's 60, this is 120. 180 minus 60 is 120. And is there any doubt that these two are x? This is isosceles
No.
because this is the radius, this is the radius. So 120 plus x equals 180. 2x is equals to 60. X is equals to 30. So either we apply it directly or we do it this way. We still get half of the angle. So this appears like this 1. I would not say this image 2 as any different than 1. So 1 is 1 and this third one is new shape. And let me just erase this and say that this is 2. So it appears like 1, it appears like 2, and it appears like 3. C even goes further down that it actually crosses one of the radius. This complete angle is 2x. This angle is x.
Oh,
So
even if it overlaps, it's still the
yes,
same.
it's still the same because this is the point C, this is A, this is B, until it is not crossing A and B wherever it stays in entire circumference. The property stays the same.
Okay.
And then we have last type. For example, this comes even further down and crosses B. It crosses B and it reaches this position. This is A, that's the center, this is B, and it reaches this position. But do not forget that if I say this is four-sided shape, A, C, B, O, see, X is actually inside the shape, 2X is outside the shape. See this 2X, that's outside that four-sided shape, this X is inside that four-sided shape.
Yes.
So in this case, when actually this angle is marked, suppose I say that this is 80. Student would confuse and say this is 40, which is wrong. So they should know that if that's 80, this is 360 minus 80, which is 280. And this is half of that angle, which makes it 140. You see this first shape, AB. Let me copy that down. This is A, this is B, this is C, and let me say this is 80 and this is 40. Now I'm not changing C, but I'm changing A and B, making them wider. So this gets wider. C stays there. A and B are moving further apart, making this 100, makes this 50. So it keeps on moving such that it actually becomes a straight line and C is still at the given position. If it is a straight line, this is 180, this is 90, half of that. A, B, C. We also call it angle subtended on diameter. Now, after this diameter, when it crosses the diameter, this is the new position. So this is 2x. and this is x. One of the angle is inside the four-sided shape, the other is outside. And the conditions are C point should always touch the circumference and the other angle should be at the center of the circle.
I don't really understand the red triangle with
There are
the
last.
yeah.
Okay. See this AB in the first one.
Yes.
Just widen the knob.
Mhm.
Widening it makes 80 move towards 100 and then 110, 120, 180 and widen it even more. Suppose this is 200. This becomes 100.
So it's widening larger than 180, but it's
Yes,
still the same.
it's
Okay.
still the same. We actually have to understand where the position is. I hope I've saved it. No, let me quickly try that. This is one of the property. The
Oh, it's
other
frozen.
try. Okay, I don't know what happened to full screen. White gets frozen. Okay, I made this circle just now. See this A, B, C, D.
Yes.
That's one of the shape. Can you see my cursor moving?
Yeah, I can.
So this angle, suppose this is 100, so this would be 50. And we do have the option of angle. So this is 116. So that is half of 116. That is 58. And this property is again half. You see, these two angles equal E and C. They're actually half of 116.03. Now see, if I just change this point, it is not allowing me to move. Please move. Yeah. You see this?
Mm-hmm.
I'm changing the distance between the lower arc and I just made it 90. See the upper angles as 45. Now
Yes.
I'm widening it. The angle is definitely getting greater, but the upper angle is always half of it. See this 130, half is 65.
Yes.
You see this, we are going closer, closer, closer to 180. Let me move the other side. So if it is 80, 180, see that 90 degree. Now it's even more than 80. Now it's close to 200. Let me try and make it 200. So if that's 200, see the angle that becomes half of it is that is 100. So these are the positioning. We just need to realize and identify that these two angles are corresponding to each other. And now see, when it stays within B and D, you see this extreme point. 96, half of 96 is 48, right?
Mm-hmm.
It stays 48. It stays 48. In this entire region, it stays 48. But when it comes down, it changes. Now, this limitation of the software, I actually wanted that angle to be inside.
But now the outside
We're
is
not looking at it. No, no, this is
yeah.
not a property. Only we are moving between D and B. Whenever we come here, we just ignore it
Okay.
for
Because
now.
it has to be at the center.
Yeah, actually, because actually I actually needed this angle, which would be half of this outside angle. This software actually has a limit. It always answers you the angle between left and right side. So if I just play the animation on,
How much can we widen the like the D and
No
E,
limit. No limit.
until it's a straight line, or can it go more
Yes.
than a straight line?
We can do that more than straight line. C when it crosses D, the point E when it crosses D. These are the shapes we need to realize. And before B, cross B, ignore that. Cross D, note that.
No, I mean because when it's at 180, it's a straight
Yeah.
line, but then afterwards we keep widening more and more and more until it's just one radius.
Yeah.
Will it still work like the 2x?
Yes, it will work. See this 96? Half
Yeah.
of 96 is 48. Now I'm widening it. And this is one of the positions I was telling you with E that it exactly overlaps the radius. 128 half is 64. Keeps moving, keeps moving, keeps moving. You're talking about 180, right?
No, not 180. More than 180, but
More than
both
180.
of them are
Will
widening until it's a one radius.
yeah, that will work. See 170 half is 85. Close to 180. 180 half is 90, right? Now I'm
Yes.
widening it even more. So we just do this. See 204 half is 102.
Yes.
We keep widening it. 240 half is 120. Oh, I never knew that I could move the angle outside. And this. See, keep on widening. This is 270, half is 135. See that? We
Yes.
keep on doing it. 152. We keep on doing it. 329, half is 164. So property always works.
But it wasn't a straight line.
Definitely straight line is only 180
No, not as in a diameter, as in just one radius.
diameter. This is diameter.
Yes.
So now what do you want? Distance between BE decreasing?
B and D like as one line.
Yeah, this is now one line. This is
No,
180.
I mean like because you keep on widening it, and then at B and D will touch.
Okay, okay, okay. So even if it just before it touches it, it's still working. See 229, half is 114. We keep widening, keep widening, keep widening. See, this is 348, half is 174. If it touches, that will become 360. Half should be 180. But that actually goes out of the limit.
Oh.
So
But
it just disappears. But for example, we don't make it 360, we make it 359.8. That will work, yes.
it'll still work.
It will still work. But definitely examiner is not going to give you that harder question. It would be difficult to identify three lines.
For example, the triangle's not in a circle, but they give it to us like as a question. Like E and the line AD are like touching,
The,
like
the property is it should touch the circumference, point B, D, E, and A is the center. The property is only valid when it touches. For example, what you're saying is we don't have that circle and we have this such something. At least I should have two equivalents which should correspond to the radius. Okay, now the circle is not given, but if someone says that this is 30 and this is 60, I am 100% sure that A, B, C would pass through a circle with common center.
I mean that also um A and B is one line and the midpoint, like it goes through the midpoint.
If it goes through the midpoint, AB is one line, this is the midpoint, this is A, this is B, and where do you want C? To right or left?
Well, it does, yeah, there. There we go.
Okay, so suppose this is C, this is how it will look like.
Yes.
Now AB, if that's a diameter without drawing a circle, it would definitely follow this. But
Even
you won't know because the circle is not there.
Oh, so for example, there's one value for 2x, let's say 60.
Yeah.
So even if it was not in a circle, but we had a question like that, then we would not be sure if x,
Yes, we will not be sure. In that case, they need to tell us that these two are equal.
and then we would be able to
Because in triangle, there are three angles, and we should know two in order to solve the third one.
if we knew that, if we knew that, let's say A and the midpoint and C was equal, would that also mean that the midpoint and B would be equal?
We can't be sure because let me just stretch that B. If I take that B at this point, it still makes the triangle, but now these two length OB and OC are different. In circle, they are actually radiuses. They are equal. So we
So
need to be sure to apply that property.
So only if BO and OC are equal, then the property will apply if it's not in a circle.
Yes.
Okay.
For sake of discussion, we are doing it, but this will never appear without a circle.
Okay.
Okay, that was one property, and this is also called the same. We actually indirectly covered this. Let me show you in writing. If I just draw this circle and this, so one of the angles, let me say this is A, this is 80. What is angle A?
40.
Angle A is 40, right? So if I draw angle B, what do you think angle B is?
40.
Angle B is 40. Now, what happens when I actually remove this 80? Will that change?
No, the degrees will still be the same.
Very
They
good. So we're naming it something. Now we are not drawing anything at the center. Let's completely ignore that. We're not drawing anything at the center. This is one of the case. These are the 2 points where it touches. This is the second one. So I'm 100% sure that these two are equal. Even if we introduced a third angle, you remember the animation when it was moving?
Yes.
The angle was always equal.
So if it's touching the two of the same points,
Yes, A and B.
yes, if it's touching A and B, then it will, like the x will always be the same all throughout.
Yes. May I call AB a chord?
Yes.
So these angles are actually on the same chord and we name them angle in same segment. Let me know, I'll explain that again. Let me know if you know the difference between these two. Segment and sector. These are two segments. And
Segment is one straight line, I believe, and yeah.
yeah,
Yeah.
okay. So whenever it is in one segment, it is always equal. And if I draw something in another segment, that is not equal.
Wait, sorry, could you repeat?
Yes. If I draw something which is in another segment, there are only two segments at a time. If it is in another segment, they are not equal. I cannot write x over here. Like if there was 40 in the first circle,
Yes.
this was this segment. And if I draw an angle over this point, this is not 40.
Yes. But
What is
rules
this?
will apply for other ones, right?
Yeah, yeah, definitely, definitely, definitely. If I have one more in this case, that would be y.
Okay.
Now, relation between x and y, we call it angle in opposite segment. This was same segment, and x and y are in opposite segment. X plus y are always equal to 180.
Oh, okay. So if it's also, let's say, a quadrilateral, let's say it's a kite,
Very nice, very nice. You
then
are always, that's a good point, one step ahead. That will lead us to our second property. Next problem. If that's a quadrilateral, if I draw this line A, B, C, D, if I draw this line, I would say A plus C is 180.
yes.
And if I do not draw this, does that change anything?
No.
And if I draw this line, B and D are in opposite segments,
So they equal to 180.
they equal to 180. So we actually name this quadrilateral cyclic quadrilateral. Either we name these two angle in opposite segment, or we name that these are opposite angles of cyclic quadrilateral. What is cyclic quadrilateral?
A square?
Those a four-sided figure whose corners touch the circumference. Now see, this is not cyclic, and no such property will be applied on this. It needs to be cyclic. If even if I have this, this is the center. This is still not cyclic. Cyclic, no.
So the center
Cyclic,
of the
no.
circle has to be the center of the quadrilateral?
It could be anywhere, no, not necessarily the center, but the corners should touch the circumference. See, this is the center, and it is not the center of my quadrilateral.
But it's still cyclic.
It's still cyclic. See another, I'll take it outside entirely, completely. This is still cyclic because A, B, C, D are still touching the circumference.
Okay. But so for this one, for cyclic, for the last one,
Yeah,
so which two would equal to, so would it be D and C?
D and B always opposite to each other. A and
Oh,
C. Because actually A and C are those which are in opposite segment.
I see. So
And
no matter if the lengths are
no matter,
equal,
no issues.
always just opposites.
Always just the opposite and touching the circumference.
Okay.
This is what you just did without looking at them. See the relationship in the first one. AC, sum of AC is 180, sum of BD is 180. In the
Yes.
second one, A is half of X, C is double of Y. Sorry, C is half of Y.
Where's, oh, yes, C is half of Y and A is half of X.
Yeah. And A plus C is
180.
180. Now, in this case, I cannot say B and D. In left hand side, B was clearly one angle, but in right hand side, if I talk about B, I'll have to be specific which angle am I talking about. This is the first line in blue, this is the second angle in green, and this is the third angle in red. I need to specify. Getting the point? This is A, B, C, D. If I'm talking about B,
Is B a 90-degree angle?
actually the magnitude is not given, so we cannot comment.
Um,
See, in this case, if I say angle A, there will be no doubt. If I say angle D, there will be no doubt that what am I talking about. But if I say B, there's a doubt because ABC or CBD or ABD. You see, one angle, second angle, and the third one.
because they're not equal.
They're not equal. And we cannot comment unless we have further data.
Okay.
Okay. Now see, let's label something. If I say this is 80, what would C be?
C would be 100.
100. Now I'm extending this line DC. What would this be?
That would be 80.
That will be 80. Yeah, now we are going to make a relation between these two. You see, if this is 70, what is D?
Then it's 110.
110. And what is the angle outside this?
70.
70. You see relation between these two?
Yes,
We
they're equal.
call it we call it exterior opposite angle of cyclic quadrilateral.
Is there like an acronym?
Is it what?
Is there an acronym?
Are you using high level vocabulary?
No, no, like
Spell it.
is it a shortened version of it?
Spell it.
Of no, of like the term that you just used, is that like a shortened version of it, just taking the first
Mm,
letters?
okay. Okay. I heard it first time.
Oh, okay.
This is A. This is B. This is C. This is D. Do we agree ABCD is cyclic quadrilateral?
Yes.
Do we agree that these two angles are equal?
Yes.
These two are equal.
Yes.
Black and black are equal.
Yes.
And the last one in blue, these two are equal.
Yep.
So this is opposite angle, exterior opposite angle of cyclic quadrilateral. Okay, now we have some fun questions. Question number one. Find the size of each lettered angle in these sketches when it is marked. O is the center of the circle.
Should I start with A?
Yeah, the first one.
Well, P is equal to 50. And then Q and R are equal to 65.
Parrot 50. So you took 180, 50 divided by 260. Very good. Q is equal to R is equals to 65. The second one. You may use calculator if you wish.
Okay. B is equal to 280?
No,
No, wait, no. B is equal to 80?
that's right. So this is 2,
280.
and then this is 80. Now, do not rush and C part and try that. Should I help?
No, it's okay.
May I just target that? Try to find C first. There are other things too which you can do in first attempt,
Okay.
but if you would just focus on C,
C is 40.
C is not 40. You see that 100? You use that 100, right?
Yes.
It is not given that the point of intersection is center of the circle.
Oh, okay. But still, like, since it's in a T position, the 100 would reflect onto the other triangle. It would be like
That's
the
we,
opposite, right?
yeah, we can take 100 on the opposite side. We can do 80 on the next side,
Yeah.
but that's not the center.
Yeah. Okay.
Okay, one thing it is not given. Maybe after finding, we can prove that this was the center, but unless until we do that, we cannot use it. But in this particular case, it is not the center for sure. May I just name a property?
Sure. Okay.
Use the property angle in same segment to find C.
Okay. C is 50.
C is 30.
30.
See this line?
Yes.
I'm going to use this chord and using this property, angle in same segment. You see this 30 and then see this C. Again, chord 30, and C. So this C is equal to 30. Angle in same segment.
So the chord is E and D,
Yes.
and then both of them are 30.
Yes.
Okay.
So this was angle in same segment. C is 30. Try D.
Is D 50?
D, doctor.
Yes.
Apply the same property. Angle at center. Sorry, angle in same segment.
I'm going to use F and 55 as the chord, but
If you use that as chord, D is not within them.
yes.
You
So
see, angle D extends and it actually meets at these 2 points. So this is the chord.
oh, so it's 55.
It's 55. You see, we studied the properties one by one, but the
Mhm.
question appears with a mix of them. So we have to recognize those lines. Now we know 30, we know 55. We can now try for E and F. Yes.
F
We
is
can find
equal.
anything first.
E and F is equal, but I think
Right.
we don't know both of them. So we can use the 80 plus 55
Very.
minus 180 and then find F, which will also be E.
So this is 80 and 55, and F is 45, and which is equal to E is 45 again.
Yes.
Try D part, doctor.
Q is 75. No, Q is not 75. Q is Q is 105,
Correct.
and then P is 85.
E.
B is 60.
B is 60. F. What is Y?
Y is 62.
Y is 62. Now X.
X is 94.
94. Now Z.
24.
Correct. Garden.
P is 85.
P85. Correct.
And then Q is 65.
Correct. Okay. In some questions, the examiner would ask you what you actually did. In some questions, he will ask you to name the property as well.
Okay.
We sometimes actually know what we're doing, but we forget the name. In the diagram, SAT is a tangent to the circle at point. At point. Okay. I need to tell you one more property. We've just indirectly discussed it. No, we've actually done it. You remember radius and tangent? They are perpendicular to each other.
Yes.
Okay. Then this is clear. Where did it go?
Well, AOB is 2x.
AOB is 2x.
I know OAT is 90, but it's more than 90.
OAT is completely 90, but for OAB, just use this triangle.
So it would just be 180 minus 2x
Yes,
divided 180 minus 4x.
divided by 2.
Oh, 180 minus 2x divided by 2
Yes,
is
that 90 minus x.
angle BAT. So angle BAT would be 180 minus x.
Now, this complete is 90, right?
Yes.
So we just remove that 90 minus x and left with x.
So it's just equal to x. Okay.
Yes. Now you see these two,
They're not equal.
x and x, are actually equal, which brings us to our next property, angle in alternate segment, and probably the last one. I'll try and share one sheet which has all the properties drawn neat and summarized.
Okay.
So this is a tangent. I'm making a triangle which is at the point of tangency. So this angle which actually touches the line and this angle which is further away from the line. So these are equal. We call it angle in alternate segment. This is the tangent at point of tangency no matter what the shape of triangle is. This blue angle equals this one, the other in green equals this one. So if you just notice this and the triangle, so x equals x, angle in alternate segment. Question number 3. Find the size of each lettered angle in these sketches when it is marked O is the center of the circle. See, he's given that O is the center, but in C part, nothing as such is given. So when it's not given, we'll not use it. What is the value of A? Can you do that?
70.
70. And B?
70.
No. This is not at
It's
the
not,
circumference.
yeah. So that's why it would be maybe 55.
That is 125. Half of 250.
Okay, so 250 because it's the outside for the other way.
Yes. C part. Go for E.
E is equal to 40.
E is equal to 80.
And then
C
F
is
is
16
equal
and F is 40.
to
They
40.
are not alternate because this arrow is not there. Okay.
Okay.
So their angle in same segment, that's 80, that's 40, and now we can work out C and D.
It's 60.
60. And number 4. In the diagram, TA and TB are tangents from point T to the circle whose center is O. AC is the diameter of the circle. Angle ACB is X. Find angle CAB in terms of X.
Did you also like which property would we use for this one?
First one, angle subtended on diameter. We also call it angle at the center is twice the angle at circumference. What would this be?
That would also be x.
Nope. If I just show you like this, this is 180 and this is 90.
So CBA would be 90.
CBA is 90. Angle subtended on diameter.
Would A be x over 2?
Which one? Which one did you say?
A.
A. Now this is actually sum of triangle. So 180 minus both of these. This is 90 minus x.
Is it not 180 minus 90? So it is just, yeah. Okay, so 90 minus x.
Yeah. So 90 minus x. B part. Find angle ATB in terms of x. A, T, B. ATB. Still working?
Yes. I know A equals to X.
A is equal to X. You know that, right?
Yes.
And then what is this? Recall the property. Two tangents from one external point. They are equal. And the question you just asked today, these two angles are also equal. So TBA is also X. Why so? Because TA is equal to TB. It is isosceles.
So the answer is 180 minus 2X?
Yes. Last one says the point P on the circumference of the circle is such that PB is parallel to CA. Express angle PBT in terms of x. PBT. Let me just write this x at a different place or the same place, and this is the unknown angle. Hmm. PBT.
Mine and 90 minus x.
That's actually not 90 because TBC is not a straight line. Do you accept that these two angles are alternate?
Yes.
So this is 90 minus x, and this complete was already x. So this unknown is complete x minus 90 minus x. Makes it 2x minus 90.
Because we remove the question mark when we do 90 minus x.
Yeah, we found out the question mark.
So we have to subtract the x.
Or you can just add these two and equate it with x.
So 90 minus x plus x.
Yeah.
So it's just 90 minus
90
9.
minus x plus the question mark gives you x.
Oh, okay. Can we write that as like an answer?
In the answer space, we will not write that as question mark. We'll write PBT. PBT.
Okay. But we can also write 2x minus 90.
Yes. Definitely the one I've written on left hand side, we will solve it one step ahead and we'll get 2x minus 90.
Okay.
Okay, for today, think, I think, hmm, hmm, I'll share this complete file, including symmetry and circles. So just go for revision. And these are some questions. If you feel like, do it. I don't want you to get frustrated. Okay.
Okay.
So this is one of the topic I'm talking like this. Like the properties are sometimes mixed and sometimes they're fine. So I'll share the complete task. It's just a revision task.
Could you also send something on indices? Because we're gonna have like a test on them on Monday.
Sure,
So
right away.
and indices. And also when we're finished with the full book, we're gonna start doing tests, right?
Yes, complete papers.
Okay. Because at the end of the year, in like 5 months, I believe we're gonna start doing like the IGCSEs in my school.
Okay, if we start doing those papers, I truly believe that specifically talking about mathematics, you'll be able to save 1.5 year.
Okay.
If you're done with papers, you can definitely. Okay. Tying your skills, the diagram shows the circular disc cut out of the square of silver sheet metal plate. The circle has a radius of 15 millimeter. O is the center of the circle. Calculate the length of the side and hence the area of the uncut metal square. Circle has a radius
The
of 15.
one Yes. Well, one length of like the square is
30,
30
correct.
millimeters. And then the
This
area would just be 9, yeah, 900.
correct. 30 into 30 is 900 millimeter square. What area of metal is left over once the circle has been cut from the square?
Okay. Pi r squared. So r is 15. 15 squared times pi. And then we subtract that with the 900.
Correct. So I'm getting 193.14 millimeter square. Mahindra makes badges by sticking an equilateral triangle onto a circular disc as shown. If the triangle has sides of 15 centimeters, find the diameter of the circular disc. Okay. Should I solve this with you?
Yes.
Would you share how you're trying this?
I was separating the triangle into three different, like,
Okay,
triangles, basically, like three different isosceles triangles.
very good.
And then trying to find it from that.
Okay, very good. So we needed to find the diameter. So if I would just get one of the sides would be the radius.
Yes.
Let's mention that as radius. Do you know what this angle is?
That angle would be 30.
Correct. This is 30 again. 30, 30, 60, 180 minus 60 is 120. So we know all these angles. and we can find the side. Which rule will we use? Do you remember trigonometry?
Yes, I do. It's sine, cos, and tan, I know.
This
So
is
we
not
can
right angled.
so we can't use any of those.
Either we can use sine rule or we can convert this into right angle.
By dividing in half, so it would be 60 and 30 and
Yeah.
90.
7.5, 30 and radius, and 60. Now if I just use 30 and 7.5, that will be cos of 30 is equals to base over hypotenuse. R is equals to 7.5 by cos of 30, and getting 5 square root 3. So diameter would be 10 square root 3. Clear?
Yes.
Number 7 says the diagram shows two chords A, C, and B, D. A, C, and B, D. In a circle, the chord intersects at point X. Use angle properties to show that the triangle ABX, one to the left, is similar to triangle CDX, one to the right. So first of all, I'm saying that BAX is equals to CDX, and I'm saying angle in same segment. Would
And
you
then
agree?
B, yes. And then BXA equals to CXD because their
BX,
angle is vertically opposite.
correct. I don't know what's happening. It keeps getting stuck. So BXA is equals to CXD, vertically opposite. Third one.
And that's just leaving the last two, which would obviously be the same because if you were to divide it by subtract it by 180, it would just leave it.
So we can just write exactly what you said, that we subtract two same angles and we get the same equal. And in this case, we just have easier way to write, that is angle in same segment, making AD the chord.
Okay.
So first part done, I can say by angle, they are similar. B part says use the fact that the two triangles are similar to show that AX and CX is equals to BX and DX. Okay. AX time AX times CX is equal to BX times DX. Now just see, we know that this angle is equal to this angle, right?
Yes.
And this and right is equal to this and right. So AX is actually something in front of a red angle, and on the other side, that is DX. So basically dividing this DX to left is equal to CX is something in front of that blue angle, and BX is something in front of Sorry, AX was in front of red and DX was in front of red, done. On the other side, in front of blue is BX and CX. BX and CX. So this is just the similar sides. When we write this, then the next step would be copying this. This is step one.
So we show that it's similar because the same links are
In similar,
in.
let me write this in this way. Do you remember we used to write this length over full length
Yes.
and then the second length over this full length? So that's what I did. AX is similar to DX. How is A? What is AX? In front of this given angle and in front of this same given angle. So AX is similar to DX divided is equals to BX, which is in front of this marked angle, and CX in front of this marked angle. So once done, now we can cross multiply. So I can say AX into CX, and cross multiplying is equals to BX into DX. Simple ratios and then cross multiplying.
Okay.
Alternate segment theorem. If I just make this tangent and draw a triangle, one of which vertex touches the tangential point. Now this angle right here, it is touching one of the chord, and this angle which is away from it are equal. And this angle is equal to this one. This is known as alternate segment. Angle in alternate segment. Whatever the shape of triangle may be. See these two in red.
Yes.
Angle in alternate segment. First one. What is the value of x?
It would be 120.
That's 120. Value of x again.
It equals to D, right?
Yes.
So that would just be 85.
Correct. X again. C part.
Now X equals to D still.
Now see the x is touching this chord. So not
Yes.
with this. It has to be away.
Okay. So it's that one. And then it'll just be 80.
That's 80. D part. Be a little thoughtful. Yeah. Where do you find x?
Because X is touching TC, it should be T to the 60 degrees. So X is 60.
It is this angle. See this chord? It
Yes.
should be away from that chord. So this is x. And relation between 60 and x in this case is angle in opposite segments.
So it is also so it'd be So it should be also 60.
No, angle in opposite segment were supplementary.
Oh, okay.
Remember this
So,
cyclic quadrilateral, or we just say, if I say this is xy, so I would say x plus y is equals to 180.
but why doesn't it also, because it's not touching the line t to the 60 degrees, but it's going through it, that's why?
Yeah, you just ignore this line. If I could replicate, so this complete x is equal to this angle.
Okay. And then should I do E?
Yes. The main art is just to recognize those lines.
Okay, so X would equal to D, and then 45 and 45 is 90, so just be another 90.
Correct. F part.
It's touching the line, so it's be that way, and that's a 30. I know that the 30 degrees is to the line that's opposite to it, and then
Okay, if we just, what should I write here?
that would be X.
And what should I write here?
That would be 30.
What should I write here?
That would also be 30.
30. What is this angle?
120
120. And what's x?
and 60.
60. And I think this was not required. Last one.
It doesn't say that it's isosceles, so triangle there. Then it would be 90. If we were to draw a straight line from T to O, would that be 90 degrees?
Very nice. Radius and tangent is complete as 90.
And then it would be 60 that would be remaining. But it's
That,
90 degrees anyways.
yes.
Um, and then 90, and then it would 30 would be the O.
No, that if that would have been on the circumference, then yes. See, in alternate segment, the triangle is not at the center, but it is at the circumference.
Oh, okay. That's
Do you
90.
agree these two are equal?
TO and OB.
No, like the radiuses.
Yes.
So this would just be 60
60.
isosceles, and that makes me do this as well.
So
Now I have
just 90 plus 60 subtracted by 180.
yes,
So that would be 30.
x is equals to 30. Okay, I'll share these remaining questions. And
Okay.
2, 3, 4. There are only three.
When will the test be?
I'll need a day to prepare. I
Yep.
think I'll be able to share it with you Sunday night, maybe after our class, and you can attempt it whenever you are available.
Okay.
Just attempt it and share for checking.
Okay.
And I'll try to use a different resource because I actually I think we had 2 or 3 questions left. Yeah, these were the
Yeah.
questions.
Yeah.
Were you able to do them?
I was able to do them. I was only having trouble with the last question. Oh no, no. I mean, sorry, the second last.
Okay. Given that O is the center of the circle, prove that 2x minus y is equals to 90. So first of all, this is 90 already.
Yes.
2x minus y equals 90. Okay. And
Oh, I'm sorry. I mixed up the questions again. It was actually question 4. Sorry.
no issues. Okay. Find the angle x. If I just draw this straight line, now these two are angle in opposite segment. I can write 100 here. And then this is 60 and 100, 160, 70, 80. This is 20. Maybe we'll use it somewhere. 37x. And this is the tangent. If this is the tangent angle in alternate segment, this should be equal to x. This is 37 and x. That's unknown.
Would 80 be reflected onto the S?
80 onto s. I don't think so. I just wrote that 100 taking ds as the chord.
Yep.
And C and that 100 angle in opposite segments. This is 80, this is 60, this is chord. And 20, 60, this would be 60. Outside, this is 80. 20. Tangent. Whatever this is equal to this. If I just get this, it's almost done. Look again. This is x.
Questions like this, there's only going to be like 1 or 2 of them, right? In the actual exam.
In the actual exam, yes, 1.
Only 1? Okay.
And maybe like even for lesser marks in one of the paper, not in 2.
Okay.
Books are sometimes tough. They had to compete in market with other books as well.
Yep. Okay. So only 1 of them.
Yes. So if I look at the larger circle, 60, that's 80, and x that is not the tangent. This is 80. This is how then is 80. This is 100. And if I just draw, this would be 60, leaving behind 20, 20. This is not the tangent, this is the tangent itself. Angle in alternate segment, this full should be 80, this is 60, this is 80, 40, 140, this is 40. So 180 minus 40 minus 37. One E. It doesn't look like 103.
Yeah, when I was doing it, I did a kind of different method, but I got 103 as well. But when I checked the marking book, like the X didn't really look like it. So I was like confused about that as well.
Do you remember the answer?
Yeah, it was 103.
Yeah, 103. So that means you got it right. This is 103. Diagram is not to scale.
Oh, okay.
Like it is obviously not obtuse, but it is.
I don't know, that confused me because it didn't look like it, but if it's not to scale, then okay.
That's it.